So good evening, students. So last class we were discussing the synopsis of haloalkanes and haloarenes. Yes, so we have discussed about the nucleophilic substitution reactions, right? So we have completed SN1 and SN2. So I'll again once explain you about the SN1 and SN2, and then we'll continue with the next part. Okay. Okay, so what are nucleophilic substitution reactions? We have seen it. What is nucleophilic substitution reaction? So they're the class of reaction in which a electron-rich nucleophile attacks a positively charged electrophile to replace a leaving group. Okay, so in that we had started with SN1 mechanism. So SN1 mechanism, it represents your unimolecular reaction. Okay, it is a substitution nucleophilic unimolecular reaction. Your SN1 reaction, it depends, or there is a two-step reaction involved. Okay, so in this, the first step, so we can see, we'll go through the, okay, so this is a reaction from tertiary butyl bromide to tertiary butyl alcohol. Okay, so how does the mechanism goes? Okay, we'll just see the mechanism. So this is the two-step reaction. Okay, two-step reaction in this. The first step is very slow step. Okay, and it is a reversible reaction. So tertiary butyl bromide. So you can see this CBr bond. It is a polar in nature. Okay, CBr bond is polar in nature. So as a result, there will be development of partial negative and partial positive charge. So as Br is highly electronegative atom, so it has a tendency to attract the electron towards itself. So this will have partial negative and this will have partial positive. So as a result, this bond will be broken heterolytically. So we have seen what is homolytic cleavage and what is heterolytic cleavage. Okay, so now you know homolytic means what? When the bond breaks, okay, the electrons are shared equally. Okay, the electrons are shared equally. And what is heterolytically? Heterolytically, the electrons are not shared equally. For example, HCl. Okay, Cl is highly electronegative bond, electronegative atom. So what it will do? It will tend to pull the electron towards itself. Okay, as a result, it will have partial negative. This will have partial positive charge. So when the bond breaks, so hydrogen will have positive charge and chlorine will take its electron pair share with it. Okay, when it is leaving. So this is about the heterolytic bond. So when this bond breaks, so what will happen? There will be formation of carbocation. So this is carbocation and this is Br minus. Okay, so Br minus means it is a leaving group. So it will take its electron pair with it. Now this is a first step. So the reversible step means what? This reaction, okay, after formation of carbocation, again it can form this starting reactant. Okay, so this is a reversible reaction. Now, second step is what? Second step is attack of a nucleophile. So, in the first step, there is a formation of carbocation. So, this carbocation is free here. So, immediately the nucleophile which is present, it will attack at this carbocation and it will form the product. So, this is the product. Okay, so these are the two steps. So, you can just go through this. So, so this reaction, it is a first order reaction. Okay, it follows the first order kinetics. Why it follows first order kinetics? Because rate okay, see here. Okay, so the rate of the reaction. So rate, okay, is directly proportional to its the concentration of the substrate. Okay, it depends only on the concentration of the substrate and not on the nucleophile. So this is the slowest step and it is a reversible step. Okay, so the bond is broken. So it depends only on the haloalkane. Haloalkane is nothing but it is a substrate. Okay, and it does not depend on the nucleophile. So this is the step 1. Then we'll see the step 2. So this is step 2. So in step 2, what happens? So as we have said now, okay, so there will be a carbocation formation. So there will be attack of the nucleophile which takes place. So here, when we are talking about the stability, tertiary carbocation is more stable than secondary and the primary. Okay, so this is always the tertiary are highly stable, then secondary and the primary. Okay, because of inductive effect. So we'll go for the next one. So next is, so this is the mechanism which we discussed. Next is SN2 mechanism. So in SN2 mechanism, it is a one-step reaction. In one-step reaction, meaning what? The breaking and moving. Okay, breaking formation and breaking of the bond takes simultaneously. Making and breaking of bond takes simultaneously. Okay, and it goes via a transition state. It goes via a transition state. So so what is happening here in SN1 mechanism? You can see there is retention of configuration. Here it is inversion of configuration. This inversion is called as Walden inversion. Okay, it is called as what? It is called as Walden inversion. Okay, since the reaction requires approach of the nucleophile to the carbon bearing the leaving group, the presence of bulky substituents on or near the carbon atom has a dramatic inhibiting effect. So you can see here. So this is a reaction. So this is the one-step reaction. So you can see CH3Br, that is methyl bromide, when it reacts with your hydroxyl group, okay, OH minus, it forms methanol, okay, plus Br minus. Now what is the okay, so here the nucleophile is attacking. So the nucleophile is attacking the carbon from the behind, okay, backside. You can see that the attack of the nucleophile is from the backside of the carbon, not from the front side. This is a front side, this is a backside. So the attack of the nucleophile, it takes place from the back of the carbon. Okay, so what is happening here? Still Br bond is there, right? You can see still the Br bond is intact. Okay, so what happens? Carbon, how many valency it has? Carbon has 1, 2, 3, 4, 5 bonds. So does carbon have 5 bonds? No. So it is penta-coordinated carbon. So carbon, when it is penta-coordinated, it is unstable because carbon can have maximum 4 valency. So here the CBr bond, it begins to break. So as this bond is making up, as the bond is been the bond is OH bond, OH is getting attached to carbon. Likewise, this bond is getting broken. Okay, so this is the penta-coordinated, or it goes via a transition state wherein the making of bond. So this is making of bond, that is, this will get attached and this will get broke. Okay, so this is making and breaking a bond takes place simultaneously via a transition state. So you can see there is complete inversion. Inversion meaning what? It is ulta, right? Here you can see your OH is attacking from behind. Here it was front. Okay, so here it is a complete inversion. Okay, so this is called as Walden inversion. So this is SN2 mechanism. So after that, we had discussed about the reaction of haloalkanes. Okay, how the alkane, okay, haloalkanes, alkyl halides will react with the various reagents. So these are the different reagents. So when it reacts with different reagents, so these are the different products which it is forming. Okay. So we had discussed about this. Yes. Physical properties is over. Nucleophilic substitution reaction is also over. Okay. I have to start with electrophilic substitution. So what do you mean by electrophilic substitution reactions? So these are the different electrophilic substitution reactions. Okay, so replacement of an atom or a group of atom through a electrophile is called as electrophilic substitution reaction. Okay, so haloarenes, they undergo usually the electrophilic reactions such as halogenation, nitration, sulfonation, and Friedel-Crafts reaction. So these are, so what you need to remember here, you need to remember the reagents. Okay, for halogenation, what is used? For nitration, which reagent is used? For sulfonation, which reagent is used? Okay, for Friedel-Crafts alkylation, which reagent is used? For Friedel-Crafts acylation, which reagent is used? Okay, which is major, which is minor? Okay, so we'll just see once again these all. Okay, so when you are doing halogenation, so it goes via Cl2, okay, Cl2 and anhydrous AlCl3, that is aluminum trichloride. You get 1,2-dichlorobenzene and 1,4-dichloro benzene. Okay, so the major product is this one, para. Okay, why? Here because of hindrance. There is steric hindrance. So due to steric hindrance, it is not possible. So due to steric hindrance, you can see it is very difficult. So it will have a minor product. So this is a major product. So this is minor. Now same with respect to nitration. Okay, so when you are doing nitration, that is with concentration of 3 and H2SO4. So this is called as nitrating agent. So you are getting, this is a minor product. Okay, and this is a major product. So what are the names? It is 1-chloro-2-nitrobenzene. Okay, and this is 1-chloro-4-nitrobenzene. Okay, so this is the name. Then when you do sulfonation, so which is the reagent used? It is concentrated H2SO4. Okay, so when you're treating it with chlorobenzene with your concentrated H2SO4, you get ortho-chlorobenzene sulfonic acid, and this is para-chlorobenzene sulfonic acid. Okay, so these are the products obtained when you are doing sulfonation. Next, very important, Friedel-Crafts alkylation, Friedel-Crafts acylation. So what is the only difference? Alkylation means there will be a alkyl group, that is CH3Cl. Okay, this is alkylation. This remains the same. It is anhydrous AlCl3. This is alkylation. Okay, so this is alkylation. So when you do alkylation with benzene, okay, so this is benzene. So that is chlorobenzene. When you do alkylation on this, so you know that the products obtained are what? The products obtained are ortho and para. Now this will be intact. Okay, so this will be what? CH3. Okay, so here this breaks here. So this is CH3, and one more product will be a para. Okay, that is CH3. So this is the alkylation. Now acylation. So what is the difference in acylation? You have to add here. Okay, you have to add CH3COCl. Okay, you have to add CO. Okay, CH3COCl. So same in the presence of anhydrous AlCl3. Okay, what you will get? So benzene, that is chlorobenzene. When you react with CH3COCl in the presence of anhydrous AlCl3, what you get? Cl, again here COCH3, because when this bond is breaking, CO is the attacking group, so it will attack at CO. So plus Cl and COCH3. Okay, so ortho and para are the products. So here what is the name? Alkylation. This is orthochlorotoluene. This is orthochlorotoluene. This is parachlorotoluene. And in acylation, this is orthochloroacetophenone. Okay, so this is acetophenone and this is parachloroacetophenone. So always the para products are major products because there will be steric hindrance in ortho products. Okay. So next we'll start with elimination reaction. Okay, so what is elimination reaction? So here you can see, so elimination reaction, or it is called as dehydrohalogenation. So two groups or atoms when attached to two different adjacent carbon atoms and simultaneous formation of multiple bonds between these carbon atoms, okay, then it leads to elimination reaction. Now, for example, so there are two types. One is alpha elimination, second is beta elimination. Now, for this, I can give you so one type of elimination here. Okay. So one is dehydrohalogenation. Dehydrohalogenation. Okay. So down it is given, it is dehydrohalogenation. So what is dehydrohalogenation? Here you can see, this is there are two adjacent carbon atoms. So on one adjacent carbon atom, there is a hydrogen, another adjacent, there is a leaving group Br. So what is happening? So there is, so when alkyl halide, so this is alkyl halide, yes, this is alkyl halide. So when alkyl halides are, this is called as alpha beta carbon, okay. So this is a alpha carbon and this is a beta carbon, okay. So when they have a beta hydrogen, okay, so it is heated. So when alkyl halide are heated with alcoholic KOH, so this is alcoholic KOH, okay, alcoholic KOH, it eliminates the hydrogen halide to form alkene. So what is happening? So you can see the reaction. Okay, what is happening here? So here, the attack of this OH is taking place at this particular hydrogen. This in turn will join and this will leave. So this you will get what? CH2. This is CH2 and CH2. And with a double bond in between. So CH2 double bond, CH2 plus KBr plus H2. Okay, so these are the product. Now, one more. This is another example. So when you have alpha beta carbon, here you can see, so CH3, CH2, CHBr. Okay, giving you here, see what will happen from here, one hydrogen will go. Okay, and you will get what? CH2 double bond CH2 plus KBr plus H2. So these are called as elimination reaction. So if they ask you which is the dehydrogenating reagent, so dehydrogenating reagent is alcoholic KOH. Remember this, okay? Dehydrohalogenating reagent is nothing but alcoholic KOH. Alcoholic KOH means your KOH is what? Potassium hydroxide is dissolved in alcohol. Okay, it is dissolved in alcohol. So it is called as alcoholic KOH. Okay, so this is, so so in this elimination reaction, so there are two types of elimination reaction. So this is alpha elimination, another is beta elimination. So there is Setzef rule. So as the hydrogen, if the hydrogen is eliminated from beta carbon, then it is beta elimination. If the hydrogen is eliminated from alpha carbon, then it is a alpha elimination. Okay, so Setzef rule, there is something called as Setzef rule, very important. So according to Setzef rule, the favored product in dehydrohalogenation reaction is the alkene with the greatest amount of alkyl groups connected to the doubly bonded carbon atoms. Okay. So if a haloalkanes, so if a haloalkane contains more than one beta carbon. Now, for example, if a haloalkane is there, okay, and it contains more than one beta carbon. So here you can see, I can give you example. So CH3, CH2, CH2, CH, Br, and CH3. Now, okay, this is what this may be beta 1. So across the this is a halogen. So this is beta 2 I can take. This is beta 1. So there are two hydrogens. Okay. So there can be two hydrogens. So when you want to do the elimination, so that is alcoholic KOH, right? It is undergoing what? Dehydrohalogenation reaction. So during dehydrogenation, if haloalkane contains more than one beta carbon, so you can see there are two beta carbons here. So then elimination will take place where the beta carbon which contains least number of hydrogen atoms, okay, or more substituted alkyl group. You can take like this. So now you can, so which is the, so this is only one. Here the alkyl groups attached to this carbon is only one. So most substituted is this side. Okay, so this what will be the product? CH3, CH2, CH double bond, CH, CH3. Okay, this is one product. Another product is CH, CH2, CH2, CH double bond, CH2. Now, which is major and which is minor? So this is highly substituted, right? So this will be major. And this is less substituted. So this is minor. Understood? So this is Sedgwick rule. So whenever you have more than one beta carbon, so you're in this, there are two beta carbons, then what you have to see? You have to see where the, what is that? Highly substituted carbon. So you have to prefer the alkene, okay, wherein the carbon will be having more substituted, highly substituted. Okay, so so that you have to follow. So this is Sedgwick rule. So next we'll see some reactions. Okay, reactions of alkyl halide with metal. So wood Fittig reaction. So we have seen wood. So wood reaction is used where? Wood reaction, it is used for two alkyl halides. Okay, when two alkyl halide reacts with sodium in the presence of dry ether gives you what? Alkane plus NaX. Okay, alkane plus NaX. So this is the reaction for wood. Fittig is what? Fittig is with two aryl groups. Okay. When two aryl groups, reacts with two NaOH, two Na in the presence of dry ether gives you what? So gives you okay. So this is a Fittig reaction. Wood Fittig means what? There will be one alkyl aryl group and one alkyl group. So when a mixture of alkyl halide and a aryl halide is treating with sodium in dry ether, so aryl arene is formed. So this is a alkyl group and arene group is formed. So this reaction is known as what? Wood Fittig reaction. So this reaction is known as what? This reaction is called as Wood Fittig reaction. So very important reaction. So you can see here Fittig reaction they have given. So when two haloarenes, so these are two haloarenes. So when they are treated with sodium in the presence of dry ether, two aryl groups are joined together, and this reaction is known as Fittig reaction. So this is a diphenyl. Okay, this is a diphenyl. So before this, can you tell me some differences between SN1 and SN2 mechanism?
Yes, ma'am.
Okay. So SN1, if I tell about SN1, okay, and this SN2, what is SN1? One difference each.
SN1 is a double step reaction. SN2 is a single step reaction.
Okay. Okay. So it involves two steps here. Okay, two steps. And so two steps with the formation of carbocation as the intermediate. Okay, in SN1 mechanism. So it involves two steps with the formation of carbocation. Okay. And what about SN2? SN2 is, it involves one step. Okay, it involves one step with formation of transition state. Okay, so this is first difference. Yes, second difference.
SN1 reaction is depends on the alkyl halides. SN2 depends both alkyl halide and nucleophilic.
Yes. So it depends upon, so rate of the reaction depends on both on the substrate. In case of SN1, it depends only on substrate. Okay. And here the rate of the reaction depends on both nucleophile and substrate. Next, which order it follows? So SN1,
Tertiary, secondary, primary.
that is the rate of reactivity. So SN1 reaction, it follows first order kinetics. Yes, first order kinetics. And SN2 mechanism, it follows second order kinetics. Then in SN1, what type of solvents are used? In SN1, what type of okay, you told about reactivity. Tertiary, yes, protic solvents. Okay, polar protic solvents, and here it is non-polar solvents are used. Okay, so your tertiary is more stable than secondary and then primary. Here primary is more stable than secondary and then tertiary. Okay, then when you're talking about here, so polar protic solvents are used, and here your non-polar solvents are used. Okay, then when you're talking about configuration, okay, what is the configuration? The product formed here is racemic mixture. Okay, racemic mixture, and here the product form is complete inversion. So these are the few differences which you have to note down. Okay, so these are the important differences which you have to note down. So I have to tell you still stereochemistry. Okay, stereochemistry I'll discuss in the next class. So these are some of the compounds which we'll study today, and then in the next class, okay, polyhalogen compounds. So polyhalogen compounds we'll discuss today, and stereochemistry I'll deal in the next class. So what are polyhalogen compounds? So the hydrocarbons or any carbon compounds containing more than one halogen atom. So you know halogen atoms, they belong to group 17 elements, okay, of the modern periodic table. So these are called as polyhalogen. Polyhalogen means what? Many numbers of halogen atoms. So when you have many or more number of halogen atoms, that is more than one in a carbon compound, then it is called as polyhalogen derivatives. The first is dichloromethane. Dichloromethane is a geminal. Okay, they are the geminal organic compound and is also called as methylene chloride or methylene dichloride. So what do you mean by geminal and vicinal? What do you mean by geminal and vicinal? Okay, I'll tell you. So here, so what it is, what they have said. Okay, dichloromethane. Dichloromethane. So it is a geminal organic compound. So how is the structure? First, I'll write the structure of dichloromethane. Okay, so this is the structure of dichloromethane. C H H H C H Cl and Cl. So this is the dichloromethane. Okay, so this is dichloromethane. So you can see that the chlorine atoms are attached to the same carbon. Okay, when the chlorine atoms are attached to the same carbon, then it is called as geminal. Okay, geminal halide or geminal compound. Okay, so this is a geminal carbon. Now, what do you mean by vicinal? So these are vicinal when the chlorine atoms, here you can see that the chlorine atoms are attached to two different carbon atoms. Okay, when the chlorine atom is attached to two different carbon atoms, then they are called as vicinal. What they are called as vicinal. Okay, so this is the meaning, geminal and vicinal. So dichloromethane, it is a geminal organic compound called as methylene chloride or methylene dichloride. So how it is obtained? It is obtained naturally from oceanic sources, that is microalgae, volcanoes and wetlands. So it is obtained there. The majority of methylene dichloride in the environment is due to industrial emissions. So from the industrial emissions means what? From the factories and all. Okay, the factories and all, they emit very industrial waste. So from that, most of the ethylene dichloride is emitted. The formula is dichloromethane is CH2Cl2. So this is about dichloromethane. So first polyhalogen compound, that is more than one halogen atom. So there are two chlorine atoms. So it is example of polyhalogen derivatives. So where it is used, dichloroethane. So it is used as a solvent in food technology. It is used in aerosol formulations. It is an ethane form blowing agent used as a solvent in the manufacturing of pharmaceutical products. Then ethylene dichloromethane, that is dichloromethane, is used as degreasing agent. Okay, it is used in the manufacturing of electronics. So these are some of the important uses of dichloromethane. Okay, then next is trichloroethane. What do you mean by trichloroethane? How is the structure of trichloroethane? Cl, Cl, Cl. So 3 Cl atoms. So more than one. So it is what is the name? It is called as chloroform. Okay, where it is used? It is called as trichloromethane. 1, 2, 3. Trichloromethane. Methane is what? CH4. So 3 hydrogen atoms are replaced with chlorine atoms. Okay, the 3 chlorine atoms. Okay, and 3 hydrogen atoms are replaced by 3 chlorine atoms. So it gives you trichloromethane. So this is another organic compound. So it is so it is used as a generally used as anesthetic. Okay, so it was first prepared in 1831. So the chemical formula is CHCl3. So it is colorless, sweet smelling, dense liquid produced on large scale. So it is used as an anesthetic and used in dentistry during root canal procedures. So when a root canal, okay, so when root canal is done by a dentist, okay, so it is very so it is very hard process. So in that, so you should not feel so much pain. So that it is used as an anesthetic. Okay. So next is the spectrum of pure chloroform is used as a reference or background, and pure cholesterol powder or cholesterol extract from milk products is dissolved in chloroform and used for FTIR analysis. So for spectrum, for removing the atomic spectra, okay, so it is used. So chloroform is used. Then chloroform was utilized in the past as an extraction dissolvable for fat, greases, oils, and different items as a laundry spot. Okay, for dissolving, so to remove the fat, then the grease, okay, oils on the this clothes. Okay, chloroform was first used for dissolving the dirt. Okay. Then used as an indirect food additive in food packaging materials for adhesive components and as a component of food contact material. So these are some of the uses. Not so important. Uses are not important. Okay, you need to remember what is the formula. Okay. Then next is tetrachloromethane. Okay, tetrachloromethane, all the 4 hydrogen atoms are replaced by chlorine. So it is a colorless liquid with a sweet smell. Okay, with a sweet smell that can be detected at low levels. The molecular formula of carbon tetrachloride is CCl4. It is used in the manufacturing of refrigerants as a cleaning agent and was also used as a fire extinguishers. Okay. Medically, it is one of the most potent hepatotoxin. So toxin to the liver and is widely used in scientific research to evaluate hepatoprotective agent. Okay, so this is very dangerous for the liver. Okay, so it is used. So medically, it is one of the most potent hepatotoxin. That is, it is very dangerous for the liver. So it is used in scientific research to evaluate the hepatoprotecting reagents. Then when carbon tetrachloride is released into the air, it rises in the atmosphere and depletes the ozone layer. So when the carbon tetrachloride is released in the air, what happens? The depletion of ozone takes place, and thus it affects the greenhouse effect. Okay, so the depletion of this ozone layer is believed to increase the human exposure to ultraviolet rays, leading to increased skin cancer, eye diseases and disorders, and possible disruptions of the immune system. So as the carbon tetrachloride is released in the atmosphere, as it begins to deplete the ozone layer. So as you know that the ozone layer is protecting the earth from the harmful rays which are coming from the sun, that is the UV rays. Okay, so when if you leave the carbon tetrachloride, the layer, that is the it will be a thin layer of ozone. Okay, so this thin layer of ozone, what it will do? It will start to deplete. So if it starts to deplete, what will happen? The human beings are more exposed to UV rays. So if you are more exposed to UV rays, so it will lead for the increased chances of skin cancer, some eye diseases and disorders. Okay, and there may be disruptions of the immune system. So this carbon tetrachloride is very hazardous. Okay. So next is iodoform. So iodoform, which is also called as triiodomethane, is a yellow crystalline solid. Okay, it is a yellow crystalline solid. So iodoform, which is also called as triiodomethane, is a yellow crystalline solid. This is insoluble in water, but soluble in solvents like ethanol, chloroform, and ether. So you know that what are the solvents? So it is insoluble in water, means it should be soluble in the organic solvents. Ethanol, okay, it is alcohol, chloroform, and a ether. So this is hydrolyzed to give you some sodium methionate. Okay, sodium methionate, that is sodium formate when treated with an aqueous sodium hydroxide solution. Iodoform, it is used as antiseptic. So in old people, they used to apply iodine, okay, as an antiseptic. If you got hurt, okay, if there is some pus, so in earlier days, people, okay, they used to use as an antiseptic, but the antiseptic properties are due to the liberation of free iodine and not due to the iodoform itself. So if there is liberation of free iodine, so thus it will have the antiseptic properties and not due to the iodoformic property. Okay, due to its objectionable smell, it has been replaced by other formulations containing iodine. Okay, because it has some different smell. Okay, so because of that, it has been different. It has been replaced by different formulations of iodine. Okay. Next, important freons. Freons are called as CFCs. So these are chlorofluorocarbon compounds of methane and ethane. The chlorofluorocarbon compounds refer to the compounds having mainly carbon, fluorine, and chlorine. So CFC is what? It is made up of fluoro, and carbons. So these chlorofluorocarbons, they mainly contain carbon, fluorine, and chlorine. Okay. So freons is the brand name for this group of compounds coined by DuPont. So these are extremely stable. They are unreactive, non-toxic, non-corrosive, and easily liquidable gases. So Freon 12 or R12, remember this? Okay, Freon 12 or R12, that is CCl2F2, is one of the most common representative of this group. Okay, so these are the two main freons. Okay, it is manufactured from tetrachloromethane by Schwarz reaction. You know what is Schwarz reaction? So from Schwarz reaction, these freons are being manufactured used by tetrachloromethane as a starting product. So these are usually produced for aerosol propellants, refrigerations, and air conditioning purposes. Okay, so CSS plays a very important role in air conditioning purposes. Next is DDT. What do you mean by DDT? It is dichloro, diphenyl, trichloroethane. Okay, so it is colorless, crystalline, tasteless, and almost odorless organochloride known for its insecticidal. Okay, so DDT, it is used as a sprayer, okay, for insecticides. So they use as spray. Okay, so it was first chlorinated organic insecticide prepared in 1873, but in 1939, Paul Miller identified the different uses of DDT. Okay, so Paul Muller, he was awarded the Nobel Prize in Medicine and Physiology for this discovery. Okay, so it became popular because of its effectiveness against the mosquito that spreads malaria and lice that carry typhus. So DDT is mostly sprayed, okay, during rainy season, because in rainy season there will be more of mosquitoes and it may cause dengue, malaria. Okay, so people spray DDT. So it is used as an insecticidal. Okay, so but due to the ill effects of DDT, such as chemical instability and fat solubility, it got banned in many countries. So before, so many they were using, but because of the chemical instability, because it is you can see dichloro DDT, that is dichloro-diphenyl trichloromethane, it is a heavy compound, so it could not get digested. Okay, the fat solubility and the chemical instability was, so it caused the ill effects. Okay, so it could not get degraded, so because of that this DDT got banned in many countries. So what are the applications of halogen containing organic compounds? It is used as solvents for relatively non-polar compounds, as a starting materials for synthesis of wide range of organic compound. Chlorine containing antibiotic chloramphenicol produced by soil microorganism is very effective for the treatment of typhoid fever. So you know the chlorine containing antibiotic, okay, that is chloramphenicol, it is produced by a soil microorganism. Okay, and it is very used for the treatment of typhoid fever. So the synthetic halogen compound, that is chloroquine. So chloroquine, it is used for the treatment of malaria. So this is also a synthetic. Synthetic means man-made. Okay, synthetic means man-made compound. So this is chloroquine is used for the treatment of malaria, and DDT, it is utilized as insecticides. Okay, so this is some of the application. So so we have completed the polyhalogen compounds. Okay, so now we have left it with the stereochemistry. So we have left it with stereochemistry. Anything else you want me to do, so that in the next class I will cover that? Yes, what else I have to do? So I have to do the stereochemistry, and anything else you want me to explain? Stereochemistry, I'll be telling about plane polarized light. Okay, what is optical activity? Then dextro and levo rotatory substances. Okay, what is specific rotation? Optical isomerism. Then we'll study about the chirality, then enantiomers. Okay, what is chiral center, asymmetric center, or asymmetric center? Okay, then racemic mixture and racemization and meso compounds. Okay, what is retention, what is inversion, what is racemic mixture? So that we'll study in the next class. Anything else I have missed, then you can tell me. I'll take that also in the next class. Yes. Only stereochemistry, right? Okay, so we'll do the stereochemistry in the next class. Okay, so we'll stop the class for today here. Okay, remaining only stereochemistry I'll do in the next class. After stereochemistry, so we have done with the synopsis, then I'll take some MCQs. Okay, so whatever we have done, that is methods of preparation, okay, substitution reaction, elimination reactions, electrophilic substitution reaction, then nucleophilic substitution reaction. So based on all those, we'll solve some MCQs after finishing this stereochemistry. Okay, so I'll stop the class now. You can leave. Thank you. What?